What's up, Nurse Cheung Bestie? Welcome to Math Bootcamp with Mr. Cheung. It's me! In this series, we're going to cover each and every single topic that you need to know for the math section for the ATIT exam, and we're going to work through some practice questions together. In this video, we're going to focus on exponent and roots. Let's get started. So there's only a couple rules that you need to know regarding exponent. It's only a couple. Let's break this down and explain it one by one. So our first rule, products rule. X with the power a multiplied by x to the power b is equal to x with a power of a plus b. What does that mean? It means that, like an example here, 2 to the power 3 multiplied by 2 to the power 4 is just equal to 2 to the power of 3 plus 4 equal to 2 to the power 7. So the next rule, we have some kind of division rule. X to the power a divided by x to the power b is just equal to x to the power of a minus b. It just reversed from the products rule. So, like this example, we have 5 to the power of 6 divided by 5 to the power of 2. We got 5 to the power of 6 minus 2 equal to 5 to the power of 4. Okay? So next rule, we got the power rule. What does that mean? If x to the power of a inside the parenthesis with another power of b, it will be just equal to x to the power of a multiplied by b. So what does that mean? Here, 3 to the power of 2 parenthesis of the power of 4 is just equal to 3 to the power of 2 multiplied by 4 equal to 3 to the power 8. So next, we have the power of the products rule. What does that mean is parenthesis of x and y, two different numbers, close parenthesis, with a power of a, is just equal to those number, x to the power a and y to the power of a. So what does that mean in number form? If 2 times 3 is inside the parenthesis of the power of 4, it's just equal to 2 to the power of 4 multiplied by 3 to the power of 4. And next we have the power of the division rule. Same rule apply. If parenthesis with x over y inside of the power a, it's just equal to x power of a divided by or over y to the power of a. So in this case, we have 4 over 5 inside parenthesis with a power of 3. It's just equal to 4 to the power of 3 over 5 to the power of 3. Now we have the last three. Zero exponent rule. What that mean is x the power of 0 is always equal to 1. Always equal to 1. So if we have 7 to the power of 0, it's just equal to 1. Next one, x to the power of a negative a. What that means is equal to 1 over x to the power of a. We just drop it down and make those numbers divided 1. So example, 3 to the power of negative 2 is just equal to 1 over 3 to the power of 2. The last one, we got this fraction exponent rule. If x to the power of a over b, it will be just equal to divide. Inside is x to the power of a divided by b times. So what does that mean? 8 to the power of 3/4 is equal to divided 8 to the power of 3 inside divided 4 times. I will further explain this a little more, what this really means. I'll take myself out so you guys can take a picture of this as a cheat sheet to remember. This exponent rule just makes some calculation a little bit faster. But you can still do it step by step, right? You can still do 2 to the power of 3 first, just 2 times 2 times 2, and then multiply by 2 to the power of 4, 2 times itself 4 times, you'll get the same answer. No different. It's just, this little step, every rule in math just make your math calculation a little bit faster. Let's do some practice together. So first, we have 3 to the power of 4 multiplied by 3 to the power of 2. We're going to do this calculation with the exponent rule first to make it faster. That's the whole point of these rules, right? So 3 to the power of 4 multiply, right? So we know it's add the power of 2 equal to 3 to the power of 6. So we know that 3 to the power of 6 is equal to 3 times 3 times 3 times itself 6 times. 1, 2, 3, 4, 5, 6. So we know that the answer will be 729. Or the answer key might just give you this, 3 to the power of 6. Okay? So this or this will be your final answer. If we don't use the exponent rule, it can still be done, right? 3 to the power of 4 is just 3 times itself 4 times. And then we keep the multiply. 3 times itself 2 times. See this setup? It's just equal to this to get the final answer. Okay? So it's pretty much the same. But if your answer key give you this, then you just need to do the math all over again. It's just extra step. But they both work. So that's why the exponent rule just make it faster. It can still be done with just regular math. But for the sake of helping you answer your question faster in this exam, these rules sometimes will be helpful. So let's try another one. So now we have the next question. 9 to the power of 5 divided by 9 to the power of 3. We know that quite easy, right? With one of the exponent rule. 9 power of 5 minus 3 is equal to 9 to the power of 2. So that could be part of the answer. Or you can continue to do the calculation, right? 9 to the power of 2 is just equal to 9 times 9 equal to 81. See, it's showing quite a bit of steps, right? Make it easier. That's the key of this exponent rule. It just helps your calculation faster. So let's do a couple more practice. So now we have 5 to the power of 2 within the parenthesis of power of 4. What does that mean? So it means that 5 with power of 2 multiplied by 4 is equal to 5 to the power of 8, right? So that, like I said, that could be part of the answer. Or if you need to do the actual calculation, it's just 5 times itself. 8 times 1, 2, 3, 4, 5, 6, 7, 8. The answer will be equal to 390,625. So now we have a negative number, negative 7 with the power of 5. What does that mean? What it means is it just negative 7 multiplied by itself 5 times, right? So we know that in the TEAS, the calculator that they provide you, there's no negative number, right? So how do we do this? So remember in the order operation, we talk about, negative number multiplication and division. We just need to do the basic calculation, multiply 7 by itself 5 times, and then use our brain to see if the answer is positive or negative. So let's do the first step. We multiply 7 by itself 5 times. Your answer will be 16,807. Okay? So now let's see our answer will be positive or negative. So let's do this, right? So how do we do this? Remember, negative multiplied by negative become positive. So next one, positive multiplied by a negative become negative. Next one, negative multiplied by a negative equal to positive. And the last one, positive multiplied by a negative equal to negative. So we know that the correct answer here will be a negative 16,807. And that's how we figure out if your answer is going to be positive or negative. We're just doing the same step, only using sign to cross it out step by step by step from left to right. See? Look at the magic of order of operation. It applies everywhere. So now we have next 5y with a power of negative 2. What does that mean, right? So what that means is we got 5, right? We know negative 2, anytime you see a negative power, we drop those numbers down over 1. Then that would be it. That would be our answer. That's what they're looking for. The next one, parenthesis 5a close parenthesis with a power of 3. What does that mean? It means 5 to the power of 3 and a to the power of 3, right? And we know that 5 to the power of 3 is equal to 125. It's just 5 times 5 times 5 3 times, and a to the power of 3. And that will be those answers that they are kind of looking for. Super easy, right? Once you know the rule, all these steps make sense. All these numbers make sense. So let's do the last one. Wow, this looks very complicated, right? But exponent rule will help us factor it out super easy. So you'll notice something familiar? Some kind of numbers inside with power, with an extra power on the outside of the parenthesis. If we open that bracket, it will be equal to 5 to the power of 2, a negative 3 multiply 2 with b with the power of 4 multiplied by 2. That would be a top, okay? And the bottom, right? We do the same thing. A with the power of 5 times 3 with a b with the power of negative 2 multiplied by 3, okay? The rest of them just basic calculation, right? 5 to the power of 2 with a negative 3 times 2 is equal to negative 6. So we got negative 6, right? B, 2 times 4 equal to 8. That's our top. Now the bottom. A with a power of 5 times 3 is equal to a to the power of 15, right? B with a power of negative 2 times 3 is equal to negative 6, okay? What do these really mean, right? Remember, this line is just a divider, right? So with a with a power of negative 6 divided by a with a power of 15, what does that actually look like? So let's break this down into 3 little sections, right? So we know that on top we have 5 over 2. So with a with power of negative 6 divided with a to the power of 15, what does that mean? It's just the numbers on the power just minus each other, right? In this case, a to the power of negative 6 is minus 15 because it divided, okay? So now on the B section, B with a power 8, right? Because we divide, it's just minus 6, negative 6, right? This will be what it formed. One more step. We're almost there, right? 5 to the power 2. We got A. Minus 6 minus 15 is equal to what? Minus 21. Now B, 8 minus 6 equal to what? 8 plus 6, right? So 8 plus 6 equal to 14. Are we done yet? We almost, right? Because we see a negative power here. So what this will form? What this will form is we still have 5 to the power 2 on the top. Now, because it's negative, right? We got negative power. We push it down, become a denominator, and keep B on the 14 on top. Okay? So you either see that, or sometimes they want you to just factor that out on the numbers. 5 times 5 equal to 25. B 14 over A 21. Like magic. But that will be your final answer. Remember, for exponent rules or some math like that, you just remember the rules and then practice, practice, practice. Be careful how you move the numbers. Everything else becomes simple based on those rules. So now, since we covered the exponent part, now we need to cover the root part, right? How we do roots. So now for roots, we got 3 different kinds, right? This, we know how to do this, right? Roots of 16 is just equal to 4 because this is just 4 multiplied by 4. But now, what does this extra index mean? So what this means is instead of this example here, make it 2. This here, some numbers multiplied by the index, the amount of times in the index will equal to the radical inside. Okay? So in this case, we will know that 3 times 3 times 3 equal to 27. So for 27 with the root of 3 as an index, this will be just equal to 3. Okay? That's what it means. So the last part, right? When it comes to exponent of x a over b, we break it down, right? Become x with power a divided by the index of b. And then the next step is we need to figure out this as whole number and the index of how many times you just divide. But most likely you won't see it, but it's good to know all these ideas, especially what this really means. It just means that they are looking for some numbers multiplied by itself 3 times because the index is 3 is equal to the radical inside. Without the number, we just know that they're looking for a multiplied by a equal to whatever inside. So the index is just meaning that whatever how many times it got divided. Okay? So now with that being taught, so how we actually do roots without a calculator? So 64. 64 is equal to what? 2 times 32. Okay? And then we break down the 32, right? Equal to 2 times 16. And then we break down the 16 here, equal to 2 times 8. And then we break down the 8 here, equal to 2 times 4. And the last part, the 4 here, is equal to 2 times 2. So 64 is just equal to 2 times 2 times 2 times 2 times 2 times 2, like I written here. And the root is what? The root for this goal is break it to even sector, right? Even part. It means that 3 of these 2 together and 3 of these 2 together, and we only want 1, right? Because that's what root means. So the answer will be 2 times 2 times 2 equal to 8. If you want to confirm if you got the root, the problem solved, just multiply 8 times itself again. Is it equal to 64? It is, right? So now we know that the way we do this root is correct. Let's do another example. We got 225 and we need to figure out the root, right? So what does that look like? Remember what we did before? 225, right? We know that 0 and 5 as a last unit, we can divide it by 5, right? So, yep, let's divide it by 5. What we have? We have 45. It's still 5, right? So let's divide it by 5 one more time. We got 9, right? Now 9, we know that we just divided by 3, right? So 225 is just equal to 3 times 3 times 5 times 5. We want an even part, right? So if we do even part, we have a 3. We have a 5 for one part. We got the other part is also 3 times 5. And we only need to calculate 1, right? So it's just 3 times 5 is equal to 15. And that will be our root for 225. Okay? Just a lot of practice. So now we have a little bigger number. We'll do that too. And this time we have 1024. Let's break this down, right? 1024. So first is we divided by 2. We got 5, 12, right? We continue to divide it by 2, right? We got 2, 5, 6, divided by 2, right? We got 128. We can continue, right? Divided by 2 equal to 64. 64, we can continue, divided by 2 equal to 32, and then divided by 2 equal to 16, right? And then we go continue here, 16 can be divided by 2, 2 and 8 can be divided by 2, and 4 can be divided by 2 and 2, okay? So for this, 1024 is equal to 2 times 2 here, 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 times 2, times 2, right? So what is the root? We want even part, right? So we have 1 set, 2 set, 3 set, 4 set, 5 set. So we know that if it's even part, it's just 2 times 2 times 2 times 2 times 2. 5 times, right? Because since we have 5 set. So this will equal to 32. So if you want to confirm it, 32 multiplied by 32 will be equal to what? 1024. So we know that this is correct. Okay? And that's how you do roots with our calculator. The reason why we call exponent and root irrational number is sometimes you can break it even. What does that mean? We have an example here to show you. If you got a number of 72 in the roots, right? Let's break the 72 down first. We got 72 divided by 2, right? Since it's even number, we got 36. Looking pretty good. We can divide it by 2 and 18, right? And 2 and 18, you got 2 and 9. 9, we got 3 and 3. So we know that 72 is just equal to 2 times 2 times 2 times 3 times 3. Okay, so obviously we have one set of 2's here. We got a set of 3's here, right? So those are easy. We just take half of it. But now we got an odd thing here, a remainder of 2. So what does that actually mean? What I mean as an answer that you should have written is 2 times 3, because those are in a set. Maintain the 2 inside the square root. So your final answer will become 6 the square root 2. That's why sometimes your calculator don't work, because if a number like this, if you use the calculator, you'll get 6.256 whatever. But that's not the answer, because you can't calculate those in real life. But you can calculate this, right? So how we calculate this? If 6 square root 2 multiplied by 6 square root 2, right? It's just equal to 6 times 6, right? Times square root 2 times square root 2. This 2 here, when we multiply it together, it's just equal to 2, right? Because half of 2 multiplied by half of 2 combined equal to 2. Multiplied by 6 multiplied by 6 is equal to 72. That's how we confirm that this square root, right, is equal to this, if that makes sense. Like a magic trick. Like a magic trick. So let's do another example. We got 162. Let's break this one down. 162, we can divide it by 2 to 81, right? 81, we can keep, divided by like 3 and 3, but, a little quicker step is 9 times 9 equal to 81. I can make all these numbers much shorter if you're confident with your numbers, right? So 9 times 9 equal to 81. So what this means is 162 is just equal to 2 times 9 times 9, right? Since we only need one set of 9's, the answer will become 9 square root 2, because the 2 is not in the set, just like that. So the root part, in the beginning, we keep dragging a lot of long numbers, right? The more practice you have, it will become a short one like this, because you're confident with your number, a bigger number, you can divide it in. Once you see something familiar, you can start dividing it in. It'll make your step much shorter. And that comes with practice. That really comes with practice, okay? So hopefully that gives you an idea on how to do roots with our calculator, especially when you're on the exam, when they give you a irrational number, all right? So let's do another example. X squared equal to 196. So we know that x squared equal to 196. It's just equal to x is equal to square root of 196, right? So now let's break the 196 down. 196, right? I can divide it by 4 equal to 49. 49 equal to 7 and 7, right? Look at me. I'm confident with my math, so I can do this step much faster. So, and now I can break this down to 2 and 2, right? Because 4 equal to 2 and 2. So it's quick, right? So 196 is just equal to 2 times 7 and times 7. So in this case, we just need one set, right? It's just 2 multiplied by 7 will be equal to 14. But is that our final answer? Because Mr. Cheung always like to trick you and teach you something, right? Yes, you're correct. The correct answer is actually plus and negative 14. Why? You're like, why? Why, Mr. Cheung, why? Okay, think about this as an exponent, right? What does that mean? X to the power 2. It's just x multiplied by itself twice, right? So, scenario 1. If the answer is a positive number, 14 times 14, oh yeah, it equal to 196. Now think about this. if x is equal to negative 14, negative 14 square, right? So times itself twice. Remember the negative rules when we come to calculation? It's still 196, right? Now we got what? A negative number multiplied by a negative number. What will the answer be? Positive. See? So technically, both number, if you plug it back as x, both positive and negative will work. See, that's why you got to be careful how the question is set up. This setup will cause you to have the answer being a positive or negative 14 because they both work when you do the actual calculation. Little trick, right? Little reminder. That's how they get you. That's how they get you. That's why everything is like a build up. You really need to understand what exponent really mean, right? You also need to think about your negative number calculation. They all pack inside as a root problem. Okay? Just example. Now I teach you, you should remember this forever. You should remember this forever. So now, next question. X to the power 3 is equal to 729. We talked about this before, right? X to the power 3 equal to 729. It's just x equal to 729 on the root of 3, okay? So regardless, we need to break down 729. So we know that 729, I can break it down to 9 and 81. We can divide it by 81 equal to 9 and 9. It's just I'm familiar with more numbers. You can start divided by 3 first, and that works too. But for me, I already know that we can divide it by 9. So 729 is just equal to 9 multiplied by 9 multiplied by 9, right? And this 3 indicate that we need to break it down to 3 parts, right? So one part here, one part here, one part here. So the final answer for x3 is equal to 9. So now you'll ask, why this time the answer is not positive and negative 9? So let's think about this, right? If a negative number multiplied with a negative number multiplied with a negative number, what would the answer be, right? Because this one, negative and negative, form a positive and negative, what would that form? We form a negative number. It's not equal to a positive number here, right? So we know that that cannot be a negative number. Just a little brain teaser right there. And that's everything you're gonna need to know when it comes to exponent and root. And as always, if you have any question, make sure to leave it down below. We love answering your question. And head over to nursecheungstore.com when there's tons of additional resources to help you feel more confident when you come to your ATIT exam. And as always, I'll catch you on the next video. Bye!